Hello everyone, welcome to EnviroPioneers. In this video, we will learn about the working principle of global positioning system, mainly focusing on the GPS signal and the trilateration method. As discussed till now, the GPS is the constellation of the satellite controlled and operated by the United States Department of Defense. And this constellation include at least 24 satellites which orbit around the Earth, and there are total 6 fixed planes which are inclined 55 degree from the equator, and the orbital period of each satellite is 11 hours and 58 minutes, which means that a satellite it orbits the earth twice per day. Now let us see how this GPS constellation is utilized in identifying the precise location of any object or any person. So each satellite in the GPS constellation, they transmit a unique signal and the orbital parameters, which is captured by the GPS devices, and they decode the signal and compute the precise location. And each of the GPS satellite, they carry very stable atomic clock that can be rubidium or the cesium atomic clocks, and these atomic clocks, they are synchronized with one another and also with the reference atomic clocks at the ground control station. And if there is any change in the clocks on the satellite from the reference time maintained on the ground station, then it is corrected regularly. And the satellite clocks are continuously adjusted to agree with the coordinated universal time, which is maintained by the United States Naval Observatory. And this coordinated universal time is the primary time standard used globally to regulate the clocks and time. And each GPS satellite, they carry the accurate record of their own position and time and broadcast that data continuously. So the data, it is broadcasted on certain carrier frequency. So these are referred as the GPS signal frequency. And in total, there are 5 frequencies at which the data is broadcasted. So here we have the L1, which is at the 1575.42 megahertz. Then we have the L2 frequency, which is at 1227.60 megahertz. And then L5, that is 1176.45 megahertz. And these three, L1, L2 and L5, these are also referred as the civilian frequencies because the data which is broadcasted on these particular frequency are available for the public users. And the data which is broadcasted on the L3, that is 1381.05 megahertz, and L4, that is 1379.913 megahertz. These are used for special purpose such as the nuclear detonation detection system and other military applications. It is important to note that the GPS satellite, they transmit on multiple frequencies. It can be L1 and L2, it can be L1, L2 and L5, or it can be L1, L2, L3. So each satellite, it can transmit on multiple frequencies, and depending upon the receiver, it can use the best signal available for their specific application, and using the multiple frequencies, it improves the receiver's performance. And among all the GPS frequencies, the L1 frequency is the most widely used frequency and is used for the navigation and timing as well as for the synchronization of the cellular network and other communication system. Now coming to the GPS signal component. So the GPS signal, it consists of 3 different components: the carrier wave, codes and the navigation message. So each satellite in the orbit, it transmits a signal on at least 2 carrier frequencies. It is L1 and L2. And the newer satellite, they also broadcast on the L5. So L1, L2 and L5, these are the civilian frequencies. And the L1 frequency, it is the primary frequency which is used by the GPS for navigation and timing and is utilized to transmit the CA code and the PY code signals. And then L2 frequency, it is used to transmit the PY code signal and is also used to transmit the L2C signal, which is the civil signal, and is available to all users. And this L2C signal, it is more precise than the CA code in the L1 frequency. Now, what is the CA code and PY code that we used just now? So this CA code, it is the course acquisition code and is the civilian code that is available to all GPS users, while the PY code is the military code which is encrypted and is available to authorized users. So in the L1 frequency, we are having the CA code as well as the precision code, while in the L2 frequency, we are having the precision code and the L2C signal. So this PY code, it is mainly for the military purpose. Then next is the L5 frequency, which is used to transmit the L5 signal and is also the civil signal which is available to all users. And this L5 frequency or the L5 signal, it is intended for high precision navigation and timing application and is more resistant to interference and the multipath. We will cover about these codes in detail, but before coming to this topic, let us understand some of the concept that is very important in the GPS system. So as we saw that each of the satellite in the GPS constellation, they broadcast the information or the signal. So this broadcast is in the form of spread spectrum waveform which generate a pseudo-random noise code. So this spread spectrum is a form of radio frequency communication in which the data is intentionally spread over a wide frequency range and it spread the signal over a broader bandwidth than the minimum required to send the information. And this process, it provides the advantage such as the increased resistance to interference and it improves the security and it enhances the privacy. So it is a type of modulation where the modulated signal bandwidth is much larger than the baseband signal bandwidth. So a spatial code that is referred as the pseudo noise, it is utilized for spreading the signal over a wider frequency range and the same code is utilized to de-spread the signal at the receiver. So here we can see that the original signal, it required only this much bandwidth, but with the help of the spreading code and with this process spread spectrum, the data or the signal, it is spread in the wider frequency range. So here we have the bandwidth of the spreaded signal and this is the bandwidth of the source signal. So spread spectrum is the basic concept through which the data is broadcasted by the GPS satellite, and this pseudo-random noise code is very important in the spread spectrum technique because the same code is required by the GPS receiver to de-spread the signal and to extract the information broadcasted by the GPS satellites. Another concept that we should know is of direct sequence CDMA in the GPS system. So this CDMA, that is the code division multiple access, this technique, it allows the several signals to be transmitted simultaneously over the same carrier frequency. In the GPS constellation, there are minimum 24 satellites and each of the satellite, they are using the same carrier frequency, that is L1, L2 and L5. So to distinguish the data or to distinguish the signal coming from each satellite as the different signal, the GPS, it uses the direct sequence code division multiple access, that is also abbreviated as DS-CDMA, and this technique, it allows the multiple satellites to transmit on the same frequency while ensuring that the receivers can distinguish the signals from different satellites. And how this differentiation is done? So that is, the data is the code specific, and how this code is generated, that is done using the spread spectrum method. So the data is transmitted from each GPS satellite as the signal using a unique pseudo-random noise code, and this is the method of the spread spectrum method. So these pseudo-random noise codes, they spread the satellite signal over a wide frequency band, making it appear as noise to unintended receiver. Means the receiver which are not having the same PRN code, they will not be able to extract the information for this particular satellite and it will be appearing as the noise for that particular receiver. For example, all the GPS satellites, they transmit on the same L-band frequency. It can be L1 and L2 and also L5. And because each satellite, they have the unique PRN code, a GPS receiver can differentiate their signals. When we will learn about codes in the GPS signal, we will also come across the terms like the binary phase shift keying and the chip rate. So let us understand about these terms here in brief. So this chip, it is defined as the pulse of a direct sequence spread spectrum code. For example, the pseudorandom noise code sequence, which is used in the direct sequence code division multiple access technique. So here if we see that this is the information which has to be broadcasted. This is the original signal and this is having only this much bandwidth. Okay, and this is spread over a wider bandwidth using the spread spectrum method. So we can see that this blue line is spread in the wider bandwidth range. So here this original information, it is spreaded out in the larger bandwidth. Now the original signal, it is given in terms of bit having the binary values with the particular sequence of 0 and 1, and this particular data, it is spreaded in the larger bandwidth using the spreading code. So here we can see this is the spreading code and this is the repetition. So here we have 10, 11, 0, 111 and then 000. And again the same sequence is there, 10, 11, 0, 111, 000 and the same repetition is there. So this spreading code, it is utilized to broadcast the original signal. But here as we can see that the original signal at some places we are having 1 and then 0, 1. So to have the simplification, we use the binary phase shift keying. So binary phase means we are having two phases. So we can see here that this particular phase, it is utilized for the 1, and for 0 we are changing the phase. So we can see that here originally it was starting from the upper mark, but by changing the phase now it is in continuation. So this is referred as the binary phase shift keying, means wherever we are having the alternate values we are changing the phase of the wave. So in this spreading code, the chip, it is the rectangular pulse. It can be either +1 or -1. So as it is mentioned here that in a binary direct sequence system, each chip is typically a rectangular pulse. It can be either +1 or -1. And the chip rate of a code is the number of pulses per second, that is the chips per second at which the code is transmitted or received. So here three things are important: chip, binary phase shift keying and then the chip rate. So binary phase shift keying is the change in the phase of the original waveform, and the chip is simply the rectangular pulse in the code. It can be either +1 or -1, whatever we are considering. And then chip rate is the number of pulse or the number of chips which are generated per second. Now, as we have understood the concept of spread spectrum, CDMA, chipping rate, binary phase shift keying, let us continue with the signal component part. So the spread spectrum technology, it is the fundamental principle used in the GPS, and with the help of the carrier wave, the GPS satellite, they continuously transmit two type of data. First is the ranging code and the second is the navigation data. So this ranging code, these are referred as the pseudo-random codes or the pseudo-random noise codes, and each of the satellite in the GPS constellation, they transmit a unique PRN code, and it helps the GPS receiver to distinguish between the signals coming from the different satellite. And this pseudo-random codes, these are of two types. One is the coarse acquisition code and the second is the precision code. So this coarse acquisition code, it is mainly intended for the civilian use and it provides the standard positioning service. And this particular code, it used the binary phase shift keying modulation technique to transmit on the L1 frequency, and it consists of 1023 bit sequence that repeats every millisecond. Now next is the precision code, and this code, it is mainly designed for the military use and it offers a more accurate positioning due to its higher chipping rate. And it also uses the binary phase shift keying modulation technique to transmit on both L1 and L2 frequency at the chip rate of 10.23 million chips per second. And in precision code, if the anti-spoofing mode of operation is activated, we refer it as the PY code. To increase the quality of service, apart from the CA code and the precision code, the modernized GPS they introduces some new signals like the L1C signal, which is mainly for the civilian use and it is broadcast on the L1 frequency, and it consists of two ranging code components, pilot and the data ranging code and the overlay code component. And here we can see that the PRN codes, they are 10,230 chips long and are transmitted at 1.023 million chips per second, repeating every 10 milliseconds. And then we have the L2C signal, which is also open for the civilian use and is broadcasted on the L2 frequency. And here it has the two unique PRN code sequence, the CM code and the CL code. And there is difference in the length of the chips. So here we can see the CM code is 10,230 chips long and it is repeated every 20 millisecond, while the CL code is 7,67,250 chips long and it is repeated every 1500 millisecond. And then we also have the M code, which is the signal restricted for the military use, and it is designed to improve the anti-jamming and the secure access for the military GPS signals. And this mainly broadcast on both L1 and L2 frequency. Then we also have the L5 frequency, which is open for the civilian use, and this L5 it supports an advanced signal structure that deliver the superior performance with a higher transmission power in comparison to the L1 and L2 signal. And this L5 signal it transmits two PRN ranging code. One is referred as the in phase code, that is I5 code, and then we have the quadrature phase code that is referred as the Q5 code. And both the codes are having the same length, that is 10,230 chips long, and are transmitted at 10.23 million chips per second and repeated after 1 millisecond. So both these codes are identical but having difference only in their initial state. So we don't have to memorize all these codes, but this was only for the understanding that from the GPS satellites we are having the broadcast of different signals, and depending upon the GPS receivers which we are using, it will be able to capture the different signals from the GPS constellation. Apart from ranging code, this signal also contain the navigation data. So this data it is required by the receiver to compute the position, and it include the information like the satellite position, clock corrections and the health status. So this navigation data is of two types, almanac data and the ephemeris data. Almanac data it provides course orbital parameter for all the satellites in the constellation and is useful for determining which satellite are in view for a given time and the location. And then we have the ephemeris data which delivers the high precision orbital and the clock correction parameter for the satellite. And this is needed to determine a satellite position, and it gives the important information about the health of the satellite, current date and the time. Now coming to the GPS services, so on the basis of the codes and the availability to civilians or the military, this GPS it provides two level of services, the standard positioning service and the precise positioning service. So the standard positioning service is the positioning and the timing services provided on GPS L1, L2 and the L5 frequencies, which are also referred as the civilian frequencies, and it is available to all the GPS users on the continuous worldwide basis with no charge. And this L1 frequency, it contains a course acquisition code and the navigation data message. L2 frequency, it contains a CM code and the CL code signal, while in the L5 frequency, we have the I5 code and the Q5 code signals. And this standard positioning service, it provides the accuracy of 9 meters with the 95% accuracy horizontally and the 15 meter with the 95% accuracy vertically, and the time transfer accuracy to UTC within the 40 nanosecond, and it is also having the accuracy of 95%. And then precise positioning service, it is highly accurate military positioning, velocity and the timing services, which is broadcasted at the GPS L1 and L2 frequencies and is available on the continuous worldwide basis to users which are authorized by the US. So it is not available for all of us, but all the users which are authorized by the US, they will be able to use the precise positioning service. And here, both the frequencies L1 and L2, they contain a precision code ranging signal with an encrypted navigation data message which is reserved for the authorized user. In the precise positioning service, the equipment is able to give us the accuracy of 2.7 meter horizontally and 4.9 meter vertically and the time transfer accuracy to UTC within 40 nanoseconds or even better. Now let us see the signal acquisition, tracking and the computation done by the GPS receivers. So the receivers, they continuously receive the signals from the multiple satellites, and since all the satellites, they transmit on the same frequency but with different PRN code, so the receivers, they match the PRN code. So they check the incoming signals against the known PRN code of the satellite, and then these signals are correlated. So by correlating the received signal with the PRN code, the receiver, it identifies which particular satellite is transmitting, and then the time delay is measured. So the receiver calculate how long the signal took to reach that particular receiver. For example, if the signal, it takes zero point 0.0 seconds to arrive, and we know that the radio waves, they travel at the speed of light, that is approximately 3 lakh kilometer per second. So when we multiply this velocity with the time, the receiver can calculate the satellite distance as the 21,000 kilometer. Once a satellite signal is acquired, the receiver, it continuously align with the PRN code, and it ensures the stable tracking even if there are slight variation due to the Doppler shift. So what is Doppler shift? This Doppler shift, it is mainly because of the continuous revolution of the satellite around the Earth, and this Doppler effect, it is considered as the apparent difference between the frequency at which the sound or the light waves leave a source and that at which they reach an observer, and it is mainly caused by the relative motion of the observer and the wave source. So the GPS receiver, they calculate the current velocity, speed and direction by measuring the instantaneous Doppler effect shift created by the combined motion of the satellites which are in the view. And the GPS receiver also extract the navigation data containing the satellite position, that is the ephemeris data, satellite clock information, alemanic data, that is the approximate position of all the satellites, and then the distance calculation is done via the pseudo ranges. So the GPS receiver needs signal from at least 4 satellites to determine the position. So the receiver, it compute the pseudo range, that is the approximate distance to each satellite, and using the trilateration, it finds the intersection of multiple distance sphere from the satellite to estimate its location. So minimum of 3 satellite is required to give a two-dimensional position, that is the latitude and the longitude, and the presence of 4 satellite, it allow the calculation of the altitude, and it fix the clock errors, enabling the precise 3D positioning. The final position computation is done using the data from the multiple satellites. So the receiver, it solves the equation for the latitude, longitude, altitude and the time, and then the coordinates are displayed either on the GPS receiver or it is sent to the navigation system. In the first diagram, here we have one GPS receiver and presence of 4 satellites. So, depending upon the position of the satellite, the time taken by the signal to reach the receiver will vary. So, here we can see that it is 0.05 second, 0.08 second, 0.07 second and then 0.06 second. On the basis of the time, the GPS receiver can calculate the distance of each of the satellite from it. So on the basis of a distance, we can consider a sphere of having the radii of this much distance. So here we can see that for this GPS receiver, we are having the 4 spheres. For the satellite 1, satellite 2, satellite 3 and the satellite 4. So determining a position by knowing your distance from at least 3 known points, it is considered as the trilateration. And in GPS, these known points are the satellite themselves. In this image, the trilateration process is described in more detail. So here the first point is that if you know that you are distance x from the satellite 1, and if you create a sphere having the same radii as the distance you calculated on the basis of the time lapse, so you could be anywhere on this particular circle, because this circle, it is a sphere in the three-dimensional space. Now if we have the distance for the second satellite and if we create the second sphere, the probability of the GPS receiver is either on these two intersection points. So to have the precise location, now we need the information of the third satellite. So when we have the distance of the third satellite from the GPS receiver and if we calculate the third sphere, so now the intersection point of all these three circles is the place where we are having the GPS receiver. So the minimum of 3 satellites are required to calculate two-dimensional position, that is the latitude and the longitude. And the fourth satellite, it synchronizes the time between the satellite and the receiver clock, and it helps us in calculating the altitude of this particular location. Similarly, in this diagram we can see that here we are having the GPS receiver. On the basis of the distance, we are having the first circle. So we can be anywhere on this circle, but when we have the information from the second satellite, now we draw the second circle here. So the probability of the GPS receiver, it increases at this particular point and here. Now when we have the information from the third satellite, now we are having the two intersection point, but because here we are having the intersection of all three circles, here this point is rejected and this is the location of the GPS receiver. And when we have the presence of the fourth satellite, the time errors and the altitude determination can be done. So in the GPS system, the trilateration method is used and it is different from the triangulation. So this trilateration, it is based on the measurement of the distance and involves the determining the location of any point by measuring the distance from that point to 3 or more known points. And it is widely used in the GPS technology where the distance from at least 3 GPS satellites is used to accurately determine the position of the receiver on Earth. And the triangulation method, it involves measuring the angle in a triangle formed by 3 known points. And it is mainly used in the surveying and the mapping where the distance between 2 known points is measured and the angle to the unknown point from these 2 points are used to determine its location. So you should remember that in the GPS technology, the working principle is the trilateration, not triangulation. So if you come across any question related to the method used in the GPS technology, you should always answer the trilateration method, because the triangulation, it is based on the measurement of the angles, while the trilateration, it is based on the measurement of the distance. And in the GPS technology, we are actually measuring the distance of the satellite from the receiver and then we are determining the position of the GPS receiver. When we use the GPS receivers, depending upon how much time is required to lock onto the satellite when they are turned on, these GPS receivers are said to have 3 types of start: hot, warm and cold. The hot start is when the GPS device remembers its last calculated position, the satellite in view, the almanac used, the UTC time, and then make an attempt to lock onto the same satellite and calculate a new position. So this type of start is the quickest GPS lock, but it only works when we are working in the same location where the GPS was last turned off. Then the second type of start is the warm start, when the GPS device remembers its last calculated position, the almanac used and the UTC time, but it does not remember that which satellite were in view. So it performs a reset and then attempts to obtain the satellite signal and calculate a new position. Then third type of start is the cold start, where the GPS device, it dumps all the information attempting to locate the new satellites and then calculate a GPS log. So among three, this is the quickest GPS log, And this one is the longest because it does not have the previous information, so it takes the longest time, and the warm start is the intermediate one. These are the references from where the content of today's video have been taken and compiled. In today's video, there was much of the written content, but because as the information was gathered from different websites, I have tried to include all the information in the video so that whenever you are referring to this video, you can get all the information related to the GPS signal or the concept related to the GPS working and the trilateration method. So I have tried my best to put all the information within this particular video related to the GPS signals. Thank you so much for your continuous support and motivation. We will meet soon in the next video covering the topic differential GPS and the real-time kinematic GPS. Thank you.